Now, robots. Am I the only one who's a bit disappointed that we don't all have a decent robot to do the housework yet? But are things about to change? In a lab in Pittsburgh, scientists are working on a robot.
There we go. Very graceful.
A robot that can load a dishwasher.
Well, that's a good solid grasp.
All by itself.
Perfectly loaded. Here, we're trying to build something like a robotic housekeeper or robotic assistant, which can move around your house and help you, for example, pick up an object and put it somewhere else, and also find new objects for you.
It's going to make it. Faith.
It's an effort by Intel Research with help from the Carnegie Mellon University Robotics Institute. The lead researchers for Intel in Pittsburgh are Dave Ferguson and Sid Srinivasa.
Too bad. At home, I'm the one who's loading the dishwasher. So this is a big incentive for me to get this working.
The robot has two parts that work as one. A robotic motion platform that gathers the mugs. And if that looks familiar to you, that's because it's the bottom part of a Segway personal transporter. The transporter has a laser scanner that looks out for moving obstacles, like people. Its computer can map paths around them so it can reach the assigned goal. The other part of the robot...
All right. Delivery?
A cable-controlled arm designed for robotic research. The arm is guided by a unique computer code called a planner. It's the newest and most important part of the system. It figures out how to maneuver its arm. It decides what mug to go after and how to grasp it.
It's got a good grip.
It extricates itself and loads the mug into a dish rack. Now you might think robots have mastered how to manipulate objects that are new to them. Not so. Usually, even demonstrations of the most advanced technology are meticulously controlled, even scripted.
There are a couple of big challenges, and the biggest problem, I think, is to be able to deal with uncertainty. Humans are able to do that very effortlessly. You don't exactly know the full 3D geometry of a mug if you're picking it up, but yet you're able to pick it up and manipulate it very easily. Whereas traditionally, the way with robots is that we model the world almost too much. The one thing that they're extremely good at doing are kind of pick-and-place operations, like building a car, where it has to do exactly the same operation over and over again. The one thing that it's not very good at doing is dealing with new actions, like people do.
Sid and the team want to design a household robot that can deal with real-world objects. So today, they're challenging the robot.
We can put it wherever we want, and we'll make it really hard.
Placing the mugs closer together makes it harder for the robot to avoid knocking one over.
The key idea here is to be able to deal with uncertainty. We didn't place the mugs at exactly some particular position because we want this to work in kind of a human setting where a person just comes and puts their mugs anywhere on the Segway. Now again, the Segway is trying to wander in so that it's within range of the arm. Again, it doesn't have to be exactly at a particular place. It's just going to get close to the arm and then stop. Now there's a camera that's pointing down from a ceiling. And what it's doing is that it's trying to figure out where the Segway is and where each of these mugs are.
The robot has a model of the mug stored in its memory. When it thinks it's found one, it marks it with a green circle. Then the planner kicks in. It uses a formula called an algorithm to intelligently sort through a library of different grasps.
Now the problem here is in trying to figure out the right grasp so that it doesn't intersect with the other mugs, which doesn't break the other mugs or let them fall down, and it results in something that's stable. And it very quickly eliminates things that don't work and zeroes in on the one grasp that works. So here again, it's coming in from the side. You see that these joints are at their limits. It's going to try to move in as close as possible, complete the grasp, it's a side grasp, so it can actually invert it, and then plan to lift it up and take it into the dishwasher rack. And it's a pretty solid grasp, as you can see.
At the moment, the arm drops the mug into the rack. But the plan is to enable it to place the mug gracefully. Today, the robot's performing well, but things haven't always gone this smoothly.
Right now, it does a very, very good job of picking up these mugs, it fails once in about 30 times. And this could be because of a whole bunch of things, like the cables could be slightly loose, or like the temperature of the day could be different. And so the arm believes that it's moving like this, whereas it's actually moving slightly faster or slower. And the inaccuracies in the arm can also lead to failure.
But most of the time, it works.
Sometimes when I watch my robot pick up a mug, and I think, this is how I would pick it up if I was one-handed and was stuck to a base. And there's something very satisfying about watching a robot execute something that's very human-like, even though you never programmed it that way.
The next step is to mount the arm on the Segway to make the whole system mobile. So when will robots be doing the dishes in your home, I hear you cry? Unfortunately, Sid thinks that's at least 10 years away. So near, and yet so far. My dream of a robot butler is still just that. But 10 years, it's not that bad.